Hello guys, welcome back again. My name is Amit and it's code time. So we are finally back again with another video, but not leak code challenges. As I promised in my last video that from now onwards we'll focus on DSA lectures and related stuff. So from now onwards we are just going to focus on data structures and algorithms. And this is going to be the first video in that journey. So I'd say no more lead code videos, no more daily challenges. And now we're going to start our journey. And so there are a lot of exciting things, interesting things going to come up for sure. And work is going continuously on the next what video we have to make, what topics we have to cover. And we'll surely, like everyone to suggest that, what topics would you want to cover. But nevertheless, from now onwards, we're going to start our journey. And yep, so we're ready to go. You have to be patient with us because it takes time to make the content, and at the same time we have to make the quality of the content, at par so that you like it. So yep, we're ready with it. So from now onwards, we'll start our data structure algorithm series. And the first video that we're going to start with, the first topic of discussion would be the time and space complexity. So without wasting any time, let's go to it. So in this video, we'll cover what is time and space complexity, what is runtime of an algorithm, how is it calculated, what are the notations involved, and what are cycles, what are processing time, and how efficient an algorithm is, why do we measure time complexity, why is it important, and all that stuff. But before moving on, I would like to discuss, why I have chosen this as the first topic of discussion. There are two main reasons. The first reason is that it's a very important topic from any point of view. Let it be, from point of view of interviews or your placement season. Okay, because in most of the cases, when you're sitting for a job or you're sitting for internship, in interviews, the recruiter might ask, the interviewer might ask you after you write, if you're done with the code, they might ask you what is the time complexity of your code and what is the space complexity of your code, right? At that point of time, you need to be thorough with this concept. You need to be correct in that case because this concept draws a line between a person who is sitting for the job and the person who gets the job. That's why this topic seems to be very small, but it's very important, right? And most of the people skip this part, and that's why that is my second reason, that most of the people undermine this topic. They're thinking that we'll learn it along the way, कि हम जब करेंगे पढ़ते हुए हम इसको कंप्लीट कर लेंगे. But to be honest, that is not the best way to do, because when you start with DSA, you should at least have the basic knowledge of time and space complexity, that how do you measure your runtime. Okay, and not even from the placement point of view, right? Not even from OA point of view, because in OAs there can be a lot of questions based on time and space complexity, that what is the runtime, what is the given this piece of code, what is the runtime of this code, what is the notation. It can be asked, right? But at the same time, as a coder, when you're solving a problem, looking at the constraints of the problem, you should know whether your algorithm would work or not. At that point of time, this concept comes very handy. That's why I have chosen this as the very first and the basic foundation of our lecture series. Right? So now, before wasting your time, we'll just start. First of all, what is time and space complexity? Right. So in general terms, when we talk about time and space complexity, right? So time is basically means time means runtime. Okay. It basically means runtime. What is runtime? Runtime basically means the time taken for the execution of the code, right? For the execution of the code. Let's say you have written a piece of code and you want to, measure the runtime, right? So basically, the execution time of a code is basically its runtime, and that is what we are going to measure. In a similar way, what is space? Space is basically the space used by the algorithm, right? Space is what? Space is memory. Memory used by algorithm, right? Used by the algorithm that you have written, right? Okay. So in generic terms, when we are talking about a definition, so this is the basic definition of time and space complexity. That what is time? Time basically means runtime, the execution time, and the space basically the memory used by your algorithm. Right. So before we delve into more complicated things, I mean more terms. First, we'll take up an example, and let's talk about the example. Let's say you want to travel from Delhi to Hyderabad. Okay. Let's say you want to travel from Delhi to Hyderabad. Okay. So we can say that we have this as this has Delhi, right? And this is, let's say, Hyderabad. Okay, this is Hyderabad. Okay, I will just write the initial. This is Delhi, and this is Hyderabad. Okay, so now you want to travel from Delhi to Hyderabad. There can be a lot of modes of travel, right? You can go by walking, you can go by cycling, you can take a bus, you can go by driving a car, you can take a train, or you can take a flight. So there are multiple ways of traveling from Delhi to Hyderabad, right? Let's say when I have made these three paths. Okay, these are basically modes of travel, right? Okay, these are modes of travel. You travel by some vehicle, you take a flight, or somewhat else, right? So basically, with each mode of travel comes a runtime, not runtime, basically the time of journey, right? when you take a train, you possibly take more time in comparison to a flight, right? Let's say I want to reach Hyderabad within 2 or 3 hours, I would take a flight. Let's say I have more time, like 15, 20 hours, I would take a train. Let's say I have more time, I will go by a car, by driving, right? And if am a superhero, I might go by cycling. And let's say I start, by walking, probably I'm dead before I reach Hyderabad, right? So basically, that is all about the journey time, right? That what amount of time would you take to reach from Delhi to Hyderabad? You can see that there are a lot of modes of travel. So each mode of travel comes with a particular comfort of time, right? In what time are you able to reach Hyderabad? So in all the cases, you can see that our starting point is Delhi and our ending point is Hyderabad. But in all the cases, we are able to reach our destination, right? Starting from the source. It is only the time taken that distinguishes between all these modes of travel. If you ask a person, he would might if he has a budget, or he would always try to take a flight, right? Because as humans, we always try to reach our destination as fast as we can. So same goes with algorithms. If we switch our places as D to be our input or parameters that we are going to give the algorithms, H is goes basically the output that we are going to get, and these arrows that I have made basically represent my algorithms. Then it is nothing different than the mode of travel. The algorithm that takes lesser time is a much better algorithm to solve a problem. If let's say you have a problem and you want to solve that problem, and we have multiple algorithms like A1, A2, A3, and their runtimes are given like T1, T2, T3, let's define them. Let's say this one takes T1, this takes T2, takes T3, right? And let's say T3 is what? T3 is lesser than T2, is less than T1. So what we can see that in all these algorithms, all these will solve the problem, right? But but T3, but T3 is T3 is the most best one, because why? It gives the least amount of runtime. In least amount of time, it will able to solve the problem. That's why we'll always prefer this algorithm, right? This is basically why we need to measure the runtime of algorithms. Which one is better and which one should we use, right? At the same time, why do we even need to measure the runtime? Okay, हमारे पास algorithms थे जो कि हमारा problem solve करके दे रहे थे, ठीक है, पर इसको मेजर करने की क्या जरूरत पड़ी, एंड व्हाई डू वी इवन नीड की इनपुट साइज का जरूरत क्यों पड़ा? ओके, हियर कम्स अ वेरी बिग क्वेश्चन, जो कि डिपेंड करता है मशीन टू मशीन. लेट्स से सम पर्सन हैज i3 लैपटॉप, मेरे पास i3 है, किसी के पास i7 है, ठीक है. अब सिंपल सी बात है, i3 के लैपटॉप पे व्हेन आई स्टार्ट कोडिंग एंड आई ट्राई टू इंप्लीमेंट एन एल्गोरिथम, the same algorithm might take different times in running on both the different systems, right? i3 might take more time in comparison to i7. क्यों? Because it's slower, right? The same algorithm will take more time in case of i3 as compared to i7. ठीक है. So this means that we have a bias, right? A bias is based on what? On the machine, the quality of machine. We need algorithms to be unbiased. If an algorithm works, then it should be unbiased on all platforms, right? But here we can see, depending upon the machine, the runtime will change. This means that we need some other standard to measure our runtime, right? In a similar way, it might be possible that if a slow algorithm is executed on a fast machine, it would take lesser time in comparison to a fast algorithm that works on a slower machine. That's why all these network parameters, or the quality of machine, the processor you are going to use, all these things will contribute to a bias. That's why we need an unbiased standard for measuring our runtime, right? What do we need? We need unbiased standard for measuring runtime, राइट? बिकॉज हम टाइम को डायरेक्टली मेजर नहीं कर सकते मशीन का यूज करके, बिकॉज वो धोखा दे सकती है. दैट इज नॉट द बेस्ट वे, क्योंकि सिंपल सी बात है, एक मशीन अच्छी है, सो इट विल टेक लेसर टाइम. दैट्स व्हाई वी नीड अ मच बेटर स्टैंडर्ड. एंड तभी हम आते हैं किस पे? अपने बिग ओ नोटेशंस पे, राइट? कि व्हाई डू वी डिफाइन all these runtime in terms of input size. उस पे आगे देंगे. Before that, it goes same with the space complexity, the amount of memory you are using. Let's say the system that you are using has a lot of RAM. Let's say you have 16 GB RAM or 8 GB RAM, or you have extendable RAM to 10 GBs, right? Then let's say you have a much better RAM in comparison to a different system. Then since you have a better RAM, the chances of an algorithm working faster is higher in your machine, right? That's why ये चीज भी है ना, मेमोरी की जो रिक्वायरमेंट है, दैट्स वाई हमें उससे भी डिवाइड होना है. We also need a good parameter for measuring the space. So that's why for measuring time and space both, we need the input size notation. ठीक है, हम input size के terms में define करते हैं अपने time और space complexity को, just in order to remove all the biases that are specific to a machine. That's why we define our algorithms in terms of their input size, कि input size के term में algorithm कैसा perform करेगा, right? So until this point, we have discussed what is time and space complexity, right? And why do we need to have a unbiased standard for measuring the runtime, and why do we need to measure runtime? Just because to get the most efficient algorithm for solving a problem, right? Now, before moving on, we also need to discuss what are cycles. Cycle क्या चीज होती है? ये cycle चलाने वाली नहीं है. दिस साइकिल इज बेसिकली रिलेटेड टू योर सीपीयू। जब आप अपना कोई खरीदते हो, क्या कहते हैं, अपना कोई सिस्टम खरीदते हो, ओके, सो बेसिकली योर सीपीयू कम्स विद देयर इज साइकिल, राइट? साइकिल क्या होती है? साइकिल इज बेसिकली, आई विल राइट, cycle is basically like a TikTok. Okay, TikTok. This is not that app TikTok. TikTok basically means once you press a, once your CPU starts execution of your algorithm or whatever instructions are going on, because your code is not the only thing that is getting executed, right? You have a lot of apps running when you open an app, when you open something else, right? And when you type something, when you give an input, or when you press a button, then there is a lot of instructions and commands going on behind that you don't know about, right? जो आपका ऑपरेटिंग सिस्टम होता है जो कर रहा होता है, इट इज कैलकुलेटिंग अ लॉट ऑफ थिंग्स इन बिहाइंड दैट यू आर नॉट अवेयर ऑफ, इट्स एब्स्ट्रैक्टेड फ्रॉम यू, राइट? So what is there? There is a cycle. Cycle is nothing but a unit of time. अभी के लिए हम जानते हैं cycle is nothing but a unit of time. What is this unit of time? ठीक है. There is something that timestamp. Let's say that means tick. Tick means that the cycle has started, and then there is a talk. Talk means the cycle has ended. Okay. Tick means cycle has started, and talk means cycle has ended. So this is basically a time frame. This time frame is basically known as cycle. ये साइकिल रिलेट होती है आपकी फ्रीक्वेंसी से। फ्रीक्वेंसी क्या चीज आप सबको पता है। आई विल डिस्कस व्हाट इज फ्रीक्वेंसी। ओके, now जब भी whenever you buy a mobile phone or a laptop or a PC or a CPU, you must have heard about processor, right? You must have heard about that, this system has 2 gigahertz processor, right? Or 1.5 gigahertz processor, right? And so on, right? What is this processor? This processor is basically related to your processing time. Processing time क्या होता है? You know what is gigahertz? Hertz basically is frequency. This frequency is actually equal to cycles, right? और यही होता है instructions. Gigahertz means 10 की power of 9, right? This means 10 to the power of 9. And what exactly does processing time mean? This 2 gigahertz means that your system can process 2 into 10 to the power of 9 instructions per second. Okay? What does it mean? This means your device or whatever your system is, your device can process up to 2 into 10 to the power of 9 instructions per second. ओके, आप जो सिस्टम है वो इतने इंस्ट्रक्शंस पर सेकंड इवेल्युएट कर सकता है, चला सकता है। दिस इज बेसिकली व्हाट योर प्रोसेसर और प्रोसेसिंग टाइम मींस। आप जो वैल्यू देखते हो 2 गीगाहर्ट्ज, 1.5 गीगाहर्ट्ज, दैट इज एक्चुअली रिलेटेड टू द नंबर ऑफ इंस्ट्रक्शंस दैट योर सिस्टम, योर सीपीयू कैन कैलकुलेट पर सेकंड। और यही आपके साइकिल रेट होता है कि आप कितने साइकिल्स को इवेल्युएट कर सकते हो विद इन अ सेकंड। ठीक है, ये बहुत इंपॉर्टेंट है। व्हाई इज दिस इंपॉर्टेंट? दिस इज इंपॉर्टेंट बिकॉज ये डिफाइन करता है कि आपका जो कोड है वो कितना टाइम लेने वाला है। वी ऑल नो द वेरी dear concept of time limit exceeded, right? We all know what is TLE, right? TLE is nothing but time limit exceeded. ये time limit exceed कैसे define होती है? That is defined by these instructions per second. Whenever you run a code, depending upon the number of instructions your code is going to evaluate or your code is going to use, the CPU can, it will evaluate instructions and it will take some time, right? अगर आपका code takes a lot of instructions that is required than the time limit for that question, right? Let's say आप कोई problem solve कर रहे हो और जो टाइम लिमिट डिफाइन है वो ऐसा है कि योर कोड, द नंबर ऑफ स्टेप्स दैट इट इज गोइंग टू यूज इज वे अबव देन द टाइम लिमिट दैट अलाउज। उस केस में आपको क्या मिल जाएगा? टीएलई मिल जाएगा। टीएलई का मतलब क्या होगा? ये जो इंस्ट्रक्शंस है ना, ये ज्यादा हो जा रहे होंगे आपके टाइम लिमिट से। लेट्स आपके पास 2 सेकंड का टाइम लिमिट है, तो इसका मतलब आप 4 इंटू 10 की पावर ऑफ 9 इंस्ट्रक्शंस पर सेकंड को कैलकुलेट कर सकते होगे अपने कोड के थ्रू। पर आपका अगर कोड ज्यादा, लेट्स से 10 की पावर 10 ऑफ इंस्ट्रक्शंस कैलकुलेट कर रहा होगा, देन योर कोड विल गिव यू अ टीएलई। दिस इज वेरी इंपॉर्टेंट। यही आपका डिसाइडिंग फैक्टर होता है व्हेन यू आर कैलकुलेटिंग द टाइम लिमिट और द पॉसिबल रन टाइम फॉर योर क्वेश्चन और फॉर योर एल्गोरिथम। दैट्स व्हाई इस पे ध्यान रखना, दिस इज वेरी इंपॉर्टेंट कि इंस्ट्रक्शन पर सेकंड क्यों काम आते हैं, राइट? सो या, so as you would remember from my earlier videos, जब मैं क्वेश्चंस करता था लीड कोड के, you must have seen I used to calculate the time, right? I used to calculate the number of instructions that we are going to take. It's, let's say हमारा n की वैल्यू 10 की पावर 5 तक जाता है and we take n square algorithm. It is how many instructions? 10 to the power of 5 square means 10 to the power of 10 instructions per second. And that is how I used to calculate whether my code will run within the time limit or not. If not, it will give you a TLE. So what I used to do, I used to just calculate my runtime using the input size, okay, and then I used to see कि मेरा कोड काम करेगा कि नहीं करेगा, right? In general it said keep, your system or any kind of machine, any platform, let's say using any platform, it generally can, can evaluate around 10 to the power of 9 instructions per second. Okay, instructions per second, that is in general the thumb rule, right? But here comes the catch. Is this value that I have written is actually on the borderline. This is a very borderline value. Let's say if you have written a code and your code is actually making these number of instructions, it is a high possibility that your code might not work. Why? Because when we are calculating this runtime, a lot of statements are there right? And we assume that the runtime for those statements is actually negligible. We neglect the runtime that is used by those statements, but in reality every statement takes some time, right? हर एक statement जो होता है, यहाँ तक कि एक if, एक see out, एक print statement, छोटा छोटा statement takes some amount of time. So we do not, we have to remember this thing, that while you are implementing, or while you are implementing implementing the algorithm that you are thinking about, it should be actually lesser than 10 to the power of 9. On, to be on the safe side, your algorithm should always be tried to, within 10 to the power of 8 instructions. This is the safe limit. This is the safe limit for, let's say your runtime is, your time limit is 1 second. Your time is 1 second. Then this is basically your safe limit, कि आप इतने instructions कर लोगे, it will be fine. आपका code चल जाएगा, right? So this is all about, what is basically runtime, what is time complexity, what is processing time, what is processor, how does it work, and why do we need all these things? Okay. But now, before moving on, to the notations, how do we calculate all these things in terms of input size, I'm going to discuss about some practical methods. Okay. I'll show you how you can actually calculate the runtime for a piece of code by using the inbuilt methods. Okay. We are going to discuss about the inbuilt methods of measuring runtime, Okay. So we'll actually calculate the amount of seconds that our code is actually taking up to execute. Okay. So अभी हम दिखाएंगे कि मतलब generally machine to machine differ करता है. What I'm trying to show you is that this the amount of time that will take, that will be shown on my screen will differ on machine to machine. कि machine के machine के हिसाब से change होता रहेगा. किसी और का PC होगा तो कुछ और run time आएगा. But इसीलिए हम क्यों use करते हैं आगे चल के notations को, right? So हम उसको बाद में देखेंगे. Now we'll just move on to implementing some piece of code and show you the runtime, how it's how you can calculate the runtime, the amount of time that your code is using, right? So to be honest, there are a lot of ways for measuring the time, the amount of time that your code takes. In C++, there are a lot of functions like get time, clock, cycles, right? There are a lot of functions, but the best among them is basically the chrono library. There's a library in C++ known as chrono. In other languages, you might have to see, what header file or what library they might use for measuring the runtime. But in C++, the best library to measure your runtime is the chrono library, right? That gives you the precise runtime. It is a very precise clock, and it gives you the runtime in very high precision. Okay, it's actually very reliable when you are trying to assess your machine in terms of running your algorithm, right? So let's start implementing some piece of code to see how it works. Okay. So I'll just write down hash include bit slash stdc bits slash stdc plus plus dot h, and using name space std, and let's create a function main, right? And now what we have to do, we will use the chrono library. So how it's declared? It's declared hash include and chrono. Okay, and that is how this library is declared. Okay, फिर हम आते हैं यहाँ पर, we like return 0. Okay, now we are basically going to start our runtime. हम जब जैसे मेन फंक्शन में घुसते हैं, we'll start measuring the runtime. What do we do? Start equal to what? Chrono. I hope so. Chrono. So yeah, chrono and high resolution clock. So we can see कि हमारे पास वो आ गया है option now, right? Now. So this is basically will mark the starting timestamp. Okay. Then we are going to execute some statements. Okay, our algorithm, whatever we are going to use, and then we'll mark the end. Okay, then we'll mark the ending stamp. This will take again chrono and high resolution clock, and now. Okay, so this will basically mark at the starting stamp and the ending stamp. Okay, now we need to calculate the amount of time taken. Time taken would be equal to what? We will equal to chrono. Okay, yeah, chrono and duration cast. So you can see duration cast, and then you just do chrono, and this will be, we'll measure it in nanoseconds. Why nanoseconds? Because in most of the cases when you are running your algorithm, it might take lesser than 1 second. So if you try to use seconds in place of nanoseconds, then it might give you 0 always. But to be on the safe side, what we'll do, we just calculate the runtime in nanoseconds, and then we'll just multiply it with the 10 power of minus 9 to get the value in seconds. Okay, and this, and then what we do, n minus start dot count. Okay, and that is how you calculate the time taken, right? And now we will print this thing. How will you print? Right, cout code executed successfully in now we'll write fixed time taken, okay, and set precision. So basically, this what we have written set precision is this is basically for up till what amount of decimal places do you want to show your answer. So I'll take 9 decimal places and slash n. Okay, and before printing this runtime, I also need to multiply it by 10 to the power of minus 9, as I said, right? So to 1e minus 9, so that we get the answer in seconds. Okay, in this number of I'll write seconds. Okay, so I think we are done here. Okay, so now let's try to just compile this piece of code and run it. Okay, what is currently the runtime? Okay, so g++ space time ppp write a.exe. Okay, so currently we can see that we do not have any code piece of code, any statements. So we can see that our code executes in 0 seconds, right? Let's say now I add a for loop. मैं यहाँ पर एक for loop add कर देता हूँ. For int i equal to 0, I less than 10, for 10 iterations i plus plus, and I do nothing. जैसे ऐसे छोड़ दिया. This will not show you any error. And now let's try to run this piece of code again. Compile and yep. So again we can see that we are getting 0.0 seconds. Why? This is basically a loop that runs for 10 times, right? यहाँ पर the amount of time taken by running just 10 iterations is not very much. That's why we can see that it's just 0.00 seconds, right? Let's say we increase the number of iterations. Let's say I make it 1,000. Let's see what effect does it has on our answer. Okay. Okay, again 0.0 seconds. Not a problem. Let's increase again. Let's make it what? Let's make it in the power of 5. No, 10 to the power of 6. Okay. Yep. Now it should take some time. I hope so. Okay. Again 0 seconds. Not a problem. Okay. Okay. If I increase this again, let's say, will it take time now? Okay. So here you can see that finally our code is taking some amount of time, right? Finally it has taken some amount of time. Still here we can see that we have not implemented any statements, right? यहाँ पर हमने just runtime calculate कर लिया, हमने कोई operation perform नहीं किया है, हमने बस simple एक loop चलाया है around 10 to the power of 10 to the power of 8 तक. Okay. Well, that is why I was saying that these things can be scary. This can be deceptive. यहाँ पर आप देख सकते हो it was 10 to the power of 8, but still it ran in 0.02 seconds. But this is actually not quite true. अगर आपको लग रहा है कि आपका 10 की पावर 8 चलाओगे आपका चल जाएगा, नहीं चलेगा. That's why I am saying that it's deceptive. इस पे इतना रिलाय नहीं करना चाहिए कि आपका जो ये क्लॉक है वो कितना टाइम बता रहा है. एक्चुअल रन टाइम डिसाइड होता है आपकी इनपुट साइज से. ओके, अब इसी को मैं दिखाता हूँ. अगर मैं कुछ वैल्यू बढ़ा दूं, लेट से मैंने एक और वैल्यू बढ़ा दी, अब देखते हैं रन टाइम चेंज होगा. 0.31 seconds. We can see that the time has increased, right? Let's say अब कुछ और चीज करके देखते हैं. Let's say I take an input. Let's say I take an input. Let's say int n and c in n. Generally आप जैसे लूप चलाते हो. So for int I equal to 0, I less than n and I plus plus. Okay, I will do nothing. मैं बस फिर से वही करूंगा. But this time we are going to take input from the code, right? चलाते हैं. Okay, so let's say I give 500. So we can see this time our code has taken what 2.08 seconds. अच्छा यहाँ पर ना इनपुट लेने का जो टाइम है ना वो भी उसमें एड ऑन हो गया है. ओके, तो अगर आपको इनपुट लेने वाला टाइम हटाना है हम वो भी हटा सकते हैं. बट इन दिस पीस इन दिस थिंग वी हैव एक्चुअली एडेड द अमाउंट ऑफ टाइम दैट वी हैव टेकन इन गिविंग द इनपुट. ओके, लेट्स ट्राई इट फॉर सम अदर वे. ओके, इस बार जल्दी से देंगे. लेट्स से 1000 enter. So we can see now 0.44 seconds. Okay, now let's try to again increase the things which submit. Yeah, now 1.93 seconds. Okay, now let's make some changes to this algorithm. Okay, थोड़ा tweak करते हैं इसको order n square का बना देते हैं. What in j equal to 0, j less than n, j plus plus. So now we can see that this piece of code has order n square time complexity. इसको आगे देखेंगे. फिलहाल के लिए इसका runtime देखते हैं कितना आता है. Okay, and we compile and now 500 दिया हमने जल्दी से. Now you can see that the time has actually increased. ठीक है, अगर मैं फिर से जल्दी दूं, let's say I take 700. Okay, you can see that as I increase my input size, the amount of time taken is also increasing. Okay, let's say अब देते हैं 1000. Okay, 2.08 seconds. Okay, let's say 2000. 1200 हो गया. Okay, ठीक है, आप देख सकते हो with each increase in input size, the amount of time taken by code is also increasing, and that's why we need a unbiased standard. Okay, so we also saw that this is not very reliable. Reliable क्यों नहीं है? क्योंकि इसमें अलग अलग टाइम पे अलग अलग चीजें होती हैं. ये इनपुट का भी टाइम कैलकुलेट करता है, बीच में दे लेता है. दैट्स व्हाई दीज आर उसमें कोई डिफरेंस नहीं, आप ऊपर की स्टेटमेंट्स कर दोगे. बट स्टिल यू कैन सी दैट इट इज नॉट वेरी रिलायबल टू कैलकुलेट द रन टाइम एग्जैक्टली बिकॉज इट कैन डिफर ऑन डिफरेंट मशीन्स. एट द सेम टाइम सेम मशीन पे ही एक एल्गोरिथम बार बार अलग अलग टाइम भी दे सकता है, आगे पीछे हो सकता है. दैट्स व्हाई इट्स प्रिफर्ड कि हम एक बेसिक स्टैंडर्ड लाएं, एक एक नोटेशन लाएं, फंक्शन लाएं, और वो होता है हमारा बिग ओ नोटेशन। ओके, एंड दैट इज व्हाट, एंड दैट इज द बिग ओ नोटेशन दैट वी आर गोइंग टू स्टडी। ठीक है, ये चीज हम नेक्स्ट वीडियो में पढ़ेंगे। व्हाट आर द नोटेशंस, व्हाट आर द एग्जाम, ठीक है, नोटेशंस क्या होते हैं, एवरेज कॉम्प्लेक्सिटी क्या होती है, बेस्ट टाइम कॉम्प्लेक्सिटी क्या होती है। ठीक है, उसके बाद व्हाट आर द रूल्स फॉर कैलकुलेटिंग टाइम कॉम्प्लेक्सिटी। ठीक है, और किस तरीके से किसी भी पीस ऑफ कोड को अप्रोच करना चाहिए, हाउ शुड बी लुक एट पीस ऑफ कोड की उसकी टाइम कॉम्प्लेक्सिटी कितनी आएगी। एंड विल ऑल्सो सी अ लॉट ऑफ इंटरेस्टिंग एग्जाम्पल्स जो कि होंगे माइंड बॉगलिंग। इट विल हेल्प यू अ लॉट, इट विल एक्चुअली पुट अ लॉट ऑफ थॉट इन योर माइंड कि इसको सॉल्व कैसे करें। ठीक है, इसका रन टाइम कितना आना चाहिए, एंड यू ऑल्सो सी सम वेरी इंटरेस्टिंग प्रॉपर्टीज जो कि आपको आगे चल के बहुत हेल्प करेंगे। ओके, सो टिल देन बाय बाय गाइस, विल मीट with another video with a part 2 very soon. तब तक के लिए साइनिंग ऑफ, बाय बाय।